Hello all. Good afternoon to all guys. So I'm launching the technical polls. Just respond to the polls whether my voice is clearly audible or not and my screen is visible clearly or not. Just respond to the polls. Everyone, please respond to the polls. Launching the technical polls. Done. Everything is good to start your class. Yes. So let's start. I'm ending the poll. Sorry. Hello everyone. So welcome to the class, everyone, guys. Today we're going to revise the top chapter, that is circle. Previously we have completed the circle chapter within 3 classes, right? So in these sessions we'll just revise all those concepts what we have studied in the previous classes. Okay, so let's start. Just a minute. Yes. Today is Makar, right? So happy Makar to all. So let's start with the revision. Okay, so what is the locus definition of circle? It is the locus of a point which moves in a plane such way that its distance from a fixed point is always constant, right? So this is the locus definition of circle. Okay, and also we have seen center. What is the center radius form and center when the center is not at origin? First case, this is the case of when the center is at origin, and this is the second case when the center is not at origin. That is, for first one, the equation is x square plus y square is equal to a square, where the center is 0, 0 and the radius is a. But in the second case, the equation becomes x minus x1 whole square plus y minus y1 whole square is equal to a square. Here the center is x1 y1 and the radius is a, right? Okay. Now already we know what is the general equation of circle, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0, where the center is minus g minus f and the radius is under root of g square plus f square minus c. So this is actually general form of the circle. Is that clear to everyone? Okay. Let's move diameter form. So what is the diameter form? That means when you have the circle, when you have the diameter of the circle and you know the coordinates of the endpoints of the diameter, then we can easily find, by using those coordinates to we can easily find the equation of circle also. What is that actually? If the endpoints are x1 y1 and x2 y2, then the equation of circle will be x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0 is the diameter form of the circle. Clear everyone? Okay. Next, parametric equation of a circle. Suppose the equation of circle is x square plus y square is equal to a square, then the parametric equations will be x is equal to a cos theta and y is equal to a sin theta, right? That means the coordinate of P becomes a cos theta and a sin theta. Is that clear to everyone? These are the parametric coordinates of the circle also. Clear? Check. Next. Circles under special conditions, right? The equation of circle touching x-axis is actually x minus h whole square plus y minus k whole square is equal to r square. That is, when circle touches x-axis, then the then the y coordinate of the center becomes the radius of the circle. Okay, then if the center is sk and the radius is k, then the equation will be what is that? X minus h whole square plus y minus k whole square is equal to k square, right? Clear, everyone? Okay. Second case, when the circle touches y-axis, then the radius of the circle becomes the x coordinate of the circle, or center of the circle. Okay. See here, in this case, when the circle touches y-axis and the center is hk, then the radius becomes h. Then the equation will be x minus h whole square plus y minus k whole square is equal to h square, right? And the third condition is if the center of the circle is r, or we can say if the equation of the circle touching both the axes. Okay, if the circle touching both the axes, then the equation will be, then the x coordinate and y coordinate of the centers are same, right? And the radius becomes y same, that is r. If we are taking the center of the circle is r, then the x coordinate is r also, y coordinate is r also, right? And the radius is r also. Then the equation will be x plus or minus r whole square plus y plus or minus r whole square is equal to r square. Clear? Again, then the last condition is when the equation passing through origin, then the equation will be x square plus 2gx plus 2fy is equal to 0, right? 0. See here. Okay, so this is all these four conditions we have, and we can get 4 different types of equation also for the circle. Clear? Okay, let's move now. Yeah, intercept made on the axis by circle. If the circle intersects x-axis only, then the length, if the circle equation of circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0, then the length of the x-intercept will be this length. Okay, suppose I'm taking this is my x-intercept made by the circle. Okay, and this length is, if this is AB, then the length of the x-intercept will be 2 into 1 root of g square minus c. Already in the previous class also we derived this formula to find the length of the intercept, right? So if the circle intersects y-axis as well, then the length of y-intercept will be, becomes 2 into 1 root of f square minus c square, right? AB. This length is called y-intercept, and the length will be 2 into 1 root of f square minus c. Clear, everyone? Okay. Sure. Let's move. Position of a point with respect to the circle. Already we derived the formula also, and we know, and it's very simple thing, very simple concept. What is S1? Guys, who can say what is S1 here? If the equation of circle is this, x square plus y square plus 2gx plus 2fy plus c is equal to 0, then if you have a point also, that is P, whose coordinate is x1, y1, right? In which conditions we can say that point is lying inside the circle or lying on the circle or lying outside the circle, right? So there are three conditions. Suppose first, if it is in lying inside the inside the circle, then S1 is less than 0. If it is lying on the circle, then S1 becomes 0. If it is lying outside the circle, then S1 is greater than 0. And so what is S1 here? S1 is, it is very simple. That is, if you need to put the given point in the left hand side of the equation, right? So after putting, what we are getting? X1 square plus Y1 square plus 2gx1 plus 2fy1 plus, so this is my S1. Okay, so if when S1 becomes 0, then we can say it is lying on the circle. If it becomes less than 0, then we can say this is lying inside the circle. And if S1 is greater than 0, then we can say that is the point is lying outside the circle. Is that clear to everyone? Clear? Let's move to the next thing. Position of a line with respect to the circle. I already derived all the things, right? Okay, so yes, just position of a line. Okay, so you can see here, if suppose this is my center, and if I'll ask you to find the perpendicular distance from center to the given line, if this is my line, then it is actually this length. Yes, no? If this perpendicular length is P, then can I say that this length P is less than R? Yes, P becomes less than R when the line intersecting to the circle. Okay, when the line intersecting to the circle. If it touches the circle, if the line touches the circle, then the length, perpendicular length will be P will be is equal to R. Right? P will be is equal to R. If it is lying outside the circle, then the perpendicular length from center to the line is actually greater than R. This is my P. Clear, everyone? Okay. Already we derived the equation of tangent also from these things. Previously, we derived the formula. So, in which conditions the tangent becomes, or the line becomes a tangent to the circle? What is the conditions of tangents? We can say, what is the conditions for a tangent, for tangents? Anyone can say? Yeah. That is when C is equal to plus or minus R into under root of 1 plus m square, right? So this is the conditions for a line to be a tangent to the circle. Clear, everyone? Okay, let's move now. When the line is like this, y is equal to mx plus c, and the circle is x square plus y square is equal to a square, then c becomes, already we discussed these things, c square is equal to a square into 1 plus m square. That is, we can also say that c becomes plus or minus a into under root of 1 plus m square. Clear, everyone? Sure. Okay. So, we already discussed these things now. Intercept made on the axis by circle, position of a point, then position of line. Okay, now we'll go through the equation of tangent. Anyone can say, how can we find if the equation of circle is given like this, x square plus y square plus 2gx plus 2fy plus c is equal to 0, and you have a point on that circle that is x1, y1, then how can you find, if I'll ask you to find the equation of tangent at the point x1, y1, okay? So what is the center becomes here? Minus g minus, right? And the coordinate of point P is x1, y. So how can you find the equation of tangents? Just reply in the chat box. What is the equation of tangent in this case? Anyone? Yes. Anyone can say. Yes. What is the equation of tangent? This is simple, yeah. Like I told you, na, what is the equation of tangents? Just you need to replace. What is the substitutions you do? You should do. Now replace x square as x1, y square as y1. Okay, x as x plus x1 by 2. Okay, and y as y plus y1 by 2. Right. So these are the substitutions you need to do. Then after substitutions, what you will get, that is my t. And t is equal to 0 is equation of tangent. So what is t? After substitutions, substitute all these things in the left hand side of the circle. Okay, so t becomes, in place of x square we need to substitute x1 plus y1 plus 2 into g into x plus x1 by 2 plus 2 into f into y plus y1 by 2 plus c is equal to 0. This is the equation of tangent at a point x1, y1 if that point is lying on the circle. Clear? Okay. So after simplifications, what you are getting, that is x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0 is your equation of tangent. If you have a point on the circle. Clear? You can find now. Okay. Next. So equation of tangent in parametric form. So what is the parametric form? That is x is equal to r cos theta and y is equal to r sin theta is a parametric equation of tangent. When you will be asking to find the parametric equation of this tangents, then you need to just use this. Okay, r cos theta, r sin theta, the point. Okay, these are the parametric coordinate of the circle also, right? Okay. Slope form is actually the equation of tangents to the circle x square plus y square is equal to r square with slope m. Hai? Simple. Can you find? Can you find? Yes or no? What is that? If suppose we are taking that y is equal to mx plus c, right? Y is equal to mx plus c is the tangent. Then conditions. What is the conditions of tangency? Conditions of tangency is m is equal. Sorry, that is y is c is equal to plus or minus r into root of 1 plus m square. Right. So substitute this in the given equation. So what is the equation you will get? That is the slope form of the equation of tangent. That is y is equal to mx plus or minus r into root of 1 plus m square. Okay. So this is the slope form of a tangent. Clear? Okay. Move. Next, some important results also. So if you have a circle and also you are having a point on that circle, that is P. Okay. then the point of coordinate of point of contact is actually this. This is my x coordinate and this is my y coordinate of the point of contact, where the at where of which point you are finding the equation of tangent. Okay, clear? Let's move. Tangent from a external point. Suppose a point is lying outside a circle. You have a point which is lying outside the circle, and you know what is the coordinate of that point. And if you are asked to find the equation of tangent, so how can you find? That is, if the slope is m, suppose I'm taking the slope of this line is m, then you know what is the perpendicular distance also here. You know the center, and you know the perpendicular distance. So from here, by using the perpendicular distance, suppose it becomes something is equal to p. Okay, then from here you can get the slope, and for slope, using the slope point form, you can find the equation of tangent, that is y minus y1 is equal to m into x minus x1. This will be the equation of tangents from an external point, right? From an external point, if you are asking to find the equation of tangent. Clear? Okay. Normal. So how can you find the equation of normal also? You know, if you are able to find the equation of tangent, then you can easily find the equation of normal also. How? If you know, if you got the equation of tangent, like suppose ax plus by plus c is equal to 0, then you know what is the slope of this tangent also. So slope of the tangent will be minus a upon b, right? Then the slope of normal becomes what is that? So because slope, tangents and normals are perpendicular to each other always, then the product of their slope will be -1, right? So slope of normal into slope of tangent, that is minus a upon b, becomes -1. Then slope of normal will be, is actually, what is that? No, that will be minus will be cancelled out, b upon a, right? So b upon a becomes the slope of this normal. Okay, if you know the slope of the normal, and also you know the point passing through the point of tangent passing through. Okay, if you know that point, suppose this is x1 y1, then you can easily find, by using the slope point form, you can find the equation of normal also. Clear? So remember, always normals and slopes, normals and tangents are perpendicular to each other, and always the normal is will be passing through the center of the circle, right? Always the normal will be passing through the center of the circle. Okay. Okay. So what is the length of tangent? Length of tangent and also power of point. Just a minute. Length of tangent is already told you, na? If you know you have the equation of circle, that is x square plus y square minus a square is equal to 0, then the length of the tangent will be L, will be on root of S1. So what is S1? So S1 is actually put the given point in the left hand side of the circle. So if you will put, what you will get, x1 square plus y1 square minus a square, right? So if this is my S1, then the length of the tangent will be on root of S1. That means this PT, this is actually my PT, this length. Okay, it becomes on root of S1. Clear? Next, length of the tangents. If the circle is in the general form, x square plus y square plus 2fy plus c is equal to 0. Here also use the same method. Length is becomes on root of s1, right? So here the equation is like this: x square plus 2gx plus 2fy plus c is equal to 0. Then put the given point, in the left hand side of that equation of circle, and then what we will get, that is represents the length of the tangent, sorry, length of the tangent. Okay, so after putting, what you are getting: x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So here, from here you will get s1, and on root of s1 will be the length of the tangent in this case. Okay, is that clear to everyone? If it is clear, then move to the next thing. Power of a point. It is very simple, है P into PB is called my power of point. PA, this length, PA, length of PA into length of PB is called the power of point. Okay. That is also, we can say, which S1 you are finding. What S1 you are finding, that is my power of point. Okay, geometrically also PA into PB is equal to PT square, so we can say. Okay, then like here we can say power of point is onto S1. Got it? Sure. Next, chord of contact. What is the equation of chord of contact? Suppose you have the equation of circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Then, if you know the coordinate of P is x1, y1, okay, then the equation of chord of contact will be T is equal to 0. Right? T, what is T? So replace x square as xx1, that is xx1 plus yy1 plus 2g into x plus x1 by 2, that is g into x plus x1, okay, plus 2 into f into y plus y1 by 2, that is 2 will be cancelled out. You'll get f into y plus y1 plus c is equal to 0. This is the equation of chord of contact from an external point. Clear, everyone? Clear? Okay. So next thing is chord with a given midpoint. Suppose you have the midpoint of the chord and the coordinates is x1, y1. Then T is equal to S1 will represent to the chord of equation of chord with the given with the midpoint x1, y1. So what is T, you know? What is T, you know? So if equation is like this, x square plus y square plus 2gx plus 2fy plus c is equal to 0, then T becomes what is T? xx1 plus yy1 plus g into x plus x1 by 2, that is 2 will be cancelled out, f into y plus y1 plus c. This becomes my T. And what is S1? S1 is put the given point in the equation, that is x1 square plus y1 square plus 2g into x1 plus 2f into y1 plus c. Then T is equal to S1 represents to the equation of chord of contact when the midpoint of the chord is given. Clear? Midpoint of that chord is given. If it is given, then you can easily find the equation of chord of contact also. Clear? Okay. So next thing is pair of tangents. So this is the equation which represents to both the tangents, that is pair of tangents. Actually, that is the equation is ss1 is equal to t square. So here I'm telling you again, if the equation is like this, x square plus y square plus 2gx plus 2fy plus c is equal to 0, then s is, what is s? S is x square plus y square plus 2gx plus 2fy. This is my x. What is s1? S1. If the coordinate of point P is x1, y1, then S1 becomes x1 square plus y1 square plus 2g into x1 plus 2f into y, right? And t, what is t? T is xx1 plus yy1 plus 2g into x1 plus x2, x plus x1 by 2, that is g into x plus x1 plus f into y plus y. So this is my t. So here, equation of pair of tangents is s into s1 is equal to t square, right? S into s1 is equal to t square represents the pair of equation of pair of tangents. Remember, got my point or not? Clear? Sure. ठीक. Please respond in the chat box if it is clear to all. Yes. Next thing, director circle. That is, it is the locus of the point of intersection of perpendicular length, tangents. Okay. In case of everything, suppose we have a parabola and here we have two tangents, those are perpendicular to each other, right? Then the locus of the point, P, suppose the intersection of both the tangents is P, then the locus of the point P is known as director circle. Okay, but in case of circle, what is happening? If these are two tangents, T1 and T2, okay, and T1 is perpendicular to T2, then the locus of the point HK, will be the director circle. So this is my director circle. And in case of circle, what is happening? Now, the equation of director circle and the director circle and the previous circles both are concentric. Concentric matlab those circles having the same center. Okay, those circles having the same center. Okay. So, and now finally, how we can relate a position of a circle with respect to another circle. Clear? And there are 5 cases. First case is when both the circles are not intersecting to each other. They are non-intersecting circles. Then the distance between the center of both the circle, okay, the length of distance between the center of both the circles will be greater than sum of the radius of both the circles. And in this case, we can draw 4 common tangents also. Clear? In the first case, when the circles are non-intersecting, then the length of the distance between the center of both the circles will be greater than the sum of their radius. And in the first case, when the circles are non-intersecting, we can draw 4 common tangents to both the circles. How? You can visualize here also. See, this is my first tangent, which is common. This is my second tangent, and this is my third tangent. Okay, and this is my fourth tangent. So 4 number of tangents, common tangents will be 4. Clear? Okay. And when both the circles are touching to each other at a single point, externally. When the one circle touches another circle externally at a single point, in that case, the length, the distance between the center of the circles, the distance between both the center of the circles will be equal to the sum of their radius. If the radius of both the circles are R1 and R2 respectively, then C1, C2, if C1 and C2 are center of the both the circles, then C1, C2 will be R1 plus R2. So in this case, we can draw three common tangents. How? Can see here, one common tangent is here, another is here, and third one is here. Clear to everyone? So in the second case, how many common tangents you can draw? Three common tangents we can draw when the one circle touches another circle externally at a single point. Okay. Clear everyone? Okay. What is the third case? Third case is if the circles are intersecting to each other. If both the circles, if two circles, if one circle is intersecting at another circle, then the condition will be, or the distance between both the centers of the circles will be greater than mod of R1 minus R2 and less than R1 plus R. And in this case, we can draw only two common tangents. You can visualize here, we can only draw two common tangents. One is this, one is this. Okay, these are the two common tangents when the circles are touch or intersecting to each other. Okay, clear? Okay, if it's circle lying inside a circle and the insider circle touches the bigger circle, the smaller circle touches the bigger one internally at a single point, in that case we can say the length of the center between the center of the circles, or the distance between the center of the circles, or C1 C2 is equal to mod of R1 minus R. And in that case only we can draw one common tangent. What is that? This is my one common tangent. Okay, and if one circle is lying inside the circle totally and it does not touches the bigger one. Okay, circle inside circles, in that case C1 C2 will be less than mod of R1 minus R2, and in this case we cannot draw any common tangents. There are zero common tangents can be drawn. Clear? Everyone clear to all? Sure, let's move. This is all about the position of a circle with respect to another circle. Now, length of tangents. In this case, first one is there are two types of tangents. One is called direct common tangents and second one is transverse common tangents. So how can you find the length of a direct common tangent? That is under root of d square minus R1 minus R2 whole square. Okay, so what is d here? Now d is the length between the centers or distance between the centers, that is this. This is my d. Okay, and R1 R2, suppose this is my R1 and this is my R2, then the length of the direct common tangent will be under root of d square minus R1 minus R2 whole square. Okay, but in the second case, in case of transverse common tangents, this is known as my transverse common tangents. Okay, and how we can find what is the formula to find the length of the transverse common tangent? That is under root of d square minus R1 plus R2 whole square. And what is d here? D is the distance between both the center. This is my d, and this is R1, this is R2. Okay, so length of the transverse common tangent is under root of d square minus R1 plus R2 whole square. Got it? Sure, let's move. Now, orthogonal circles. When we can say both the circles are orthogonal, that means simply if the angle between two circles is 90°, we can say those circles are orthogonal to each other. Okay, so orthogonal means 90°. So you can ask, sir, how we can find the angle between two circles? Is it possible? Yes. Actually, the circles are always represented by the tangents. It is saying equally, equally that the angle between the circles is equal, or it's very similar. It's equal with the angle between their tangents also. If the circles are represented by tangents, then the angle between the tangents is called also the angle between the circle also. And what we are saying in case of orthogonality, or when we can say both the circles are orthogonal to each other, now when the angle between two circles, or we can say angle between the tangents is 90°, then we can say orthogonal circles. Both the circles are orthogonal. Is that clear to everyone? Yes. If it is clear, let's move to the next thing. Family of circle. Okay, so equation of family of circles. The first case is, there are four cases. And the first case is the equation of family of circles passing through point of intersection of two circles. If two circles are intersecting to each other, so the point of intersections will be 2. Number of point of intersection will be 2. And passing through these 2 points, how many circles you can draw? Those are called actually the total system. The total number of circles is called actually the family of circles, right? If suppose if these are the points of the red wala circle and black wala circle, intersecting points, then passing through these 2 points, how many circles you can get? You can draw infinite number of circles. So this total infinite number of circle is called family of circles. So what is the equation? If first is S is equal to 0 and the second equation is S dash is equal to 0, then the equation of family of circles will be S plus lambda S dash is equal to 0. So when you can change the values of lambda, when you will change the values of lambda, you will get another new circles passing through these 2 points. Suppose here I'm taking a lambda is equal to 1. That means lambda, for lambda is equal to 1, this equation becomes S plus S dash is equal to 0. It's a new circle passing through those 2 points. If I'll put lambda is equal to 2, then it becomes S plus 2 S dash is equal to 2. This is the circle also passing through these 2 points. So you can, in place of lambda, you can take any values. You can take any values and you will get so many circles, and those circles are called family of circles. Okay, sure. Second case, what is the second case? if a line intersecting the circle at 2 points, when the line is intersecting to the circles, we are getting the point of intersections at 2. So passing through those 2 points also, we can draw many circles, infinite number of circles also. And the equation will be representing to, if the circle equation is S is equal to 0 and the line equation is L is equal to 0, then the family of circles will be S plus lambda L is equal to 0. S plus lambda L is equal to 0. Clear? Okay. Third one is, if you have a line, okay, and that line is a diameter to the circle, and the equation of circle is will be, if this point is P and this point is Q, the coordinate of P is x1 y1, the coordinate of Q is x2 y2, and this is PQ is the diameter. PQ is the diameter of the circle S. Then the equation of circle will be x minus x1 into x minus x2, diameter form, plus y minus y1 into y minus y2. Okay, and if I'll take any general point on the line, on that diameter, suppose it is xy, any point on that line xy, then the equation of line will be this. If these 3 points are collinear, then this determinant. So here also this expression represents to my equation of circle, and this represents to my line. So here also the equation becomes s plus lambda L is equal to 0. This is represents to your family of circle. Clear? Yes or no? And the fourth case, that is the last case, when a circle, equation of family of circle touching a fixed line. Okay, touching a fixed line, then the equation of circle will be, the center is actually center. If center is x1, y1, and the equation of family of circles touching a fixed line. Okay, leave this. Touching a fixed line. Suppose this point is x1, y1. Okay, then the equation of line will be y minus y1 minus m into x minus x1 is equal to 0. And the equation of circle passing through these points will be x minus x1 square plus y minus y1 square. So here also we are getting s plus lambda L is equal to 0. This represents to the family of circles also. Clear, everyone? Okay, so these are the things, these are the concepts which we have covered in the previous 3 classes. Okay. So if I'll ask you one question, you need to find the tangents drawn from the origin to the circle is x square plus y square plus 2ax minus 2by plus b square is equal to 0 are perpendicular. Then find the value of a square plus b minus b square. This is a question for you as your homework. You can take it as your homework question also. Another question I'm giving. Suppose you need to find, let the tangents drawn from the origin to the circle. Write the question. Let the tangents drawn from origin to the circle x square plus y square minus 8x minus 4y plus 16 is equal to 0, and it starts it at the point points A and B. Then you need to find AB square. What is AB square? You need to find. So options are, first option is 52 by 5. Second option is 56 by 5. And third option is 64 by 5. And the last option is 32 by 5. So there are the 4 options. Which one is correct? You need to find. So these are 2 questions. You can take it these 2 questions as your homework questions. Please find the solutions and try to solve both these questions and come with the answers to the next class. And in the next class or tomorrow, what we'll do, we'll solve some previous year questions. We'll solve some previous year question, guys. Okay, in the next class we'll do. Okay, so that's all for today's class. Thank you all. Bye bye. Take care, everyone. because it's time and you have another class also. So let's end here the class for today. Thank you all. Bye bye.